Hey guys, Myers Mathematics, and let's just jump right into it. So, why are there powers of I? Okay, and if you clicked on this video because you were looking for something to explain an easy way to get powers of I, this is exactly what this is going to be. Okay, now what people normally do is they start with I and they say I equals the square root of -1, which is true, right? And then they go on to say that I squared, of course, would be I times I, or like if you were to square both sides, right? So let me pull this out for a second. So sometimes teachers don't explain this part that well, so I'm going to. If this is the square root of -1, and I square both sides, okay, what that means is I'm multiplying it by itself, but what that also means is that the square and the square root cancel. Why? Well, because they're opposites, right? It would be like saying y is multiplying by 2 and then dividing by 2 going to get me the same number as what I started with. They're opposites, right? Plus is the opposite of minus, times is the opposite of divide, and then powers are the opposite of roots. Power. Powers are the opposite of roots. So they cancel, which means then that I squared is equal to just -1. Good so far? Okay. So then teachers normally go on to go with the I cubed and then the I to the fourth power. So I'm going to do those real quick. And then I'm going to show you why you don't really need to even go to I to the fourth when you use this trick. Okay? And it's not a special trick. Every teacher tells you this trick if they're worth their salt. But let me go ahead and explain how you get to the I cubed and the I to the fourth power. So I cubed, little history on powers. If you have a number, or in this case, um, a letter, right, which is a number that it's represented by the letter, if I multiply it by itself, that means it's squared. Anything times itself is squared. Well, anything times by itself 3 times would be cubed. This is I cubed, okay, which is what we're trying to find. Now, I times I is I squared. So that means I squared times I equals I cubed. Right? That's what that means. Now, this is good for us because then we can just plug in what we already know and figure out what we need to know. I squared, we already know, is -1. I is the square root of -1. Therefore, I cubed is -1, but I'm going to leave out the 1 because you don't need it, negative square root of -1. Okay? So that then is I cubed. And you might ask, well, why don't the negatives cancel? Well, that's a good question. The negatives don't cancel because they're in different places. If you have um, two things that normally cancel out, right? Like, let's say, let's say you owe the pizza man money. He takes an IOU, right? Let's say you order pizza and you're like, oh, I don't have any money on me, but you know the pizza guy, and he's like your friend, and you're like, oh, let me just do an IOU, and I'll get you next time, right? So you owe him money. So right, this negative right here is the fact that you owe the pizza man money. Now you order pizza again, okay? So what that means is the pizza man's at your door, okay? And that's a negative because of the money, right? Where it's good because you're getting pizza, right? Pizza's always good. But it's negative because you need to pay him and you already owe him money. But until he comes through the door, until you open the door to him, right? You don't owe him that money. You can't give him the money until he comes through the door. So there's a negative outside the door and there's a negative inside the door. But since the door hasn't been opened for the negatives to, come together and cancel out, they don't. Okay, and that's not like a mathematical example, it's just a way to remember that your negatives don't cancel. Okay, when you're inside of a square root, it's like protected, it's like under protected status, it's a safe space. Right, so that's what's happening there. And then I to the fourth power, we don't really need to talk about this, but a lot of teachers go from I to the first to I to the fourth, and then show you that you repeat a pattern. So I might as well go ahead and do this here. So we already know that I squared is -1. Okay. Now, if I square this, if I square I squared, anytime you take a power to a power, if you take a power to a power, you multiply the powers. Okay. So that's what I'm going to do. So then I have -1 squared, which is -1 times -1, which is just 1. Now, the reason why you take a power to a power is because whenever I have a power to a power, it's basically like saying I'm multiplying it by itself. Well, I'm multiplying it by itself, which means really that there's 4 of these altogether, right? I times I times I times I. Okay, so that's what's going on there. But if you have a power to a power, you multiply the powers. That's the rule. Okay, now we get 1. So the problem with how teachers normally teach this concept is that I to the fourth power equaling 1 is not the last thing before it starts repeating. It's actually the first time it repeats. So I to the 0 power is actually the beginning of this pattern. Okay? I to the 0 power, anything to the 0 power is 1, including I, even though it's an imaginary number. Anything to the 0 power is 1. I is still a number. It's not a real number, but it's a number. Anything to the 0 power is 1. Okay? So I to the 0 power is 1. Now, when you get to I to the fourth power, it repeats, and then afterward, after this point, from 0 to 3, right, a total of 4 things, from 0 to 3 is your pattern. Then when you get to I to the fourth, and so on, it repeats over again, right? So it's just square root of -1, this would be negative, or sorry, not yet. That's square root of 1, so this is -1. I to the 7 be negative square root of -1, and then we'd get 1 again, right? So, and so on and so on. 8, 9, 10, all the way to infinity, okay? So the pattern is actually starting at 0 and going to 3, and then when you repeat every number, every fourth power of I is going to have the same as its previous one. Well, here's what you could do, right? If I want the I to the 10 power, if it repeats every 4 times, what I could do is I could just say, I'll just subtract by 4. So now that's going to be I to the 6th power. Okay, I'm not in my standard I to the 0, I to the 1, I to the 2, I to the 3 series yet, so I'm going to do it again, -4. Okay, if I do that again, I get I squared. Oh, hey, hold on. I squared is -1. I squared is -1, so that's the answer. -1. Okay, I squared equals -1, which means that I to the 10th power is equal to -1 as well, right? That's what we're trying to find. And you're probably also wondering at some point, like, why do we even learn this? Okay, and you're right in that it doesn't really have a lot of good application to it. It's fine. I don't mind saying that. Really, the only application when you delve into things like imaginary numbers would have to do with like a series, like a circuit series, like electricity and things like that. So electrical engineering. So if you want to be an electrical engineer or an engineer in general, you're definitely going to need to know your imaginary numbers. But if not, you're probably not ever going to run into them. Imaginary numbers are really not used for much else. There's some applications that I've heard of outside of engineering, like with aviation. There's certain formulas that you can create for aviation to optimize your airplanes that are easier whenever you use complex formulas, meaning like formulas with I in them. So they're out there. There's other applications out there. Don't get me wrong, but there's already somebody who's created a program where you just type in basic numbers, right? Like integer type numbers, 1, 2, and 3 numbers, and it does all the math for you. So there's already been somebody that's engineered this and figured this out. So really, there's not a huge there's not a huge need for this, for these powers of I. So if you've been like, oh, when am I ever going to use this? Well, you're probably not, unless you're going to be engineering something um, that has an application with this. So that's the answer to that question. But there is probably a test coming up on this, right? And my goal is to get you to pass every single test ever so that you get math out of the way if you're going to be a non-math major in college or trade school or whatever. If you're going to be a non-math person in your career, then you need this, to graduate, and then that's it, right? So let's jump back into the trees. Let's take a forest view. I can take a broad picture view there for a second. Let's jump back into the topic. So the trick to getting any of these problems right is you could do this, right? You could just keep subtracting 4 over and over and over again. But the easier way would be to just divide. And you're probably like, well, yeah, I already knew we're dividing, but like, how did you get that from subtracting? Well, subtracting, repeatedly subtracting, is division. Okay? So if I repeatedly add something, 3 plus 3 plus 3 plus 3, okay, let's say I add it 4 times. And I kind of just gave it away by saying it because you can't even really say it without hinting at multiplication. If I add 3 to itself 4 times, that's 3 times 4. That's the meaning of multiplication, is repeated addition. Well, the same holds true for repeated subtraction. If I subtract something, minus 3, minus 3, minus 3, minus 3, okay, then the same holds true. Okay, there's not quite as direct of an application, so I'm not going to continue on with this here. But basically, all you need to know is that if I have repeated addition, that's multiplication. If I'm repeatedly subtracting something, then I'm dividing. So let's do that. Right? Let's use the same example. And instead of subtracting by 4, I'm going to take I to the 10, and I'm going to take the 10 and divide it by 4. Right? And how many times does it go in? Well, ironically enough, and it's not really ironic when you think about it, I had to subtract 4 twice before I got a low number, right? I squared is a low power. I had to subtract it twice. Well, lo and behold, 4 goes into 10 twice, evenly without going over 10. So 2 times 4 is 8, right? Standard division rules here. And then I have 2 as a remainder, so I squared is my answer. The remainder is the answer. And this is what trips people up when they learn this trick. They learn this trick and they're like, oh, the remainder is the answer. But the problem happens when you get a problem like this. So what if I said I to the 80th power, right? Well, me just creating this problem out of thin air, I knew exactly what this was right off the bat. Because 80 goes into 4 evenly, right? So if I use this trick of dividing it by 4, it goes in evenly. It goes in exactly 20 times, right? So I have 0 as a remainder. Now, according to my trick here, you can just take the remainder, take I to that power, and you're done. Well, you can still do that. I to the 0 power, you're done, right? Which equals 1. Now, what your teacher normally does to teach you this is they say that if you have a 0 remainder, that means that you should write it as I to the fourth power. Okay? And if your teacher is grading you strictly on this and says that if you don't write I to the fourth power, you get it wrong, then I would recommend doing that. You want to get the right answer according to your teacher, because your teacher, not me, is the one grading your test. So, play along. But if I get a zero remainder, that's just I to the zero power. Doesn't that make more sense to have I to the zero? Just put an I to that power and you're done. Okay, that's all you have to do. Now, if you get a zero remainder, that means it's I to the zero. But according to textbooks and teachers mostly, most textbooks and teachers, I should say, they're going to want this answer. Okay, for whatever reason. That's the answer they want. They want I to the fourth power. When really you don't need to write it as I to the fourth power. Okay, so that's all that I have to say about that. Why are there powers of I? Well, to answer that question, there are powers of I because it's a number. So you can take it to any power you want because I is a number. And then the reason behind the question, so the question behind the question is, why do I have to learn this, or how do I apply this, or things like that, right? So that is what I meant to go through in the video. So yeah, so check this out. I have a guide, the 5 math mistakes everyone makes and how to avoid them. Long title, but basically, in my 10 years of tutoring and 4-ish years of teaching in private school and public school, I noticed that every time a student missed a problem, it was for 5 different reasons and 5 reasons only. And that is what I wrote this little guide about for you, is those 5 things that everyone misses. I can narrow it down to 5 things. Those 5 things. And if you can avoid those 5 things, being aware of what they are, then you will never miss a math mistake. Again, it's a good little guide to have on hand. I want to give it to you for free. Check it out. It's on my website, myersmathematics.com. Same as my channel.